Welcome to the Talking Reliability podcast, where the future of maintenance meets the power of sound. Hosted by Chris Hallum from UE Systems, we're diving deep into the world of predictive maintenance, asset reliability, and cutting-edge ultrasound technology. Whether you're on the plant floor or leading reliability strategies, pull up a chair, or better yet, grab your hard hat, because we're bringing you real talk, real stories, and real insights from the experts who keep industries running. Let's crank up the volume on reliability. Hi everyone, welcome to Talking Reliability podcast, and today we're looking at the Predictive Technology series. First up is going to be thermal imaging, and today we have a good friend, and our guest is Jason Cargill from FLIR. Hi Jason, how are you doing?
I'm good, Chris. Thanks very much for having me on.
Oh, you're welcome. It's brilliant to have you. And Jason has been in this sort of area for a long time, so he's a great person to have on board, and he's going to hopefully share with us some great information on thermal imaging and what FLIR do. So, Jason, would you like to start by giving a bit of an introduction to yourself?
Yep, certainly. I mean, you've mentioned I've been in this industry for a long time, so you're obviously trying to tell me that I'm old. But technically, I suppose maybe. I am. But yeah, the background is I'm a time-served electrical engineer. Spent the early part of my career with a switchgear manufacturer for a number of years. Then moved into the world of test and measurements in the kind of early 2006 actually. And I've been in field sales ever since. I've been now with FLIR for the last just over 5 years. So test and measurement's been the sort of the bulk of my experience in the last 25 years.
Excellent. Thanks, Jason. Then what about FLIR itself? Would you be able to give us a bit of a rundown on FLIR for those that don't know who FLIR are, maybe?
Yeah, certainly. I mean, FLIR, the name itself, it stands for forward-looking infrared. So that's where the brand name comes from. FLIR was founded back in the 70s, a very good decade, because I was also founded in the 70s. And essentially what we specialise in is thermal imaging technologies. And that's what we are known for in the industry, is for thermal imaging cameras specifically. But we have many divisions within FLIR. So I work on what's called the portable division for kind of condition monitoring solutions. But we have a fixed science, first responders, for example, fire brigades and police forces. And then we have a military division, and we have a number of other divisions, as we're now part of the Teledyne Technology's digital imaging division. So FLIR as a business was purchased by Teledyne towards the end of 2021. And that's where the Teledyne name becomes linked with FLIR. But we're still very much forward-looking infrared as a business. We've introduced other technologies as well over the years. So from a condition monitoring perspective, we have other solutions in addition to thermal imaging. But predominantly our technologies are to provide a full solution in the region of predictive preventive maintenance.
Oh, that's fantastic. And it's a very large organisation, isn't it? And I must admit, I do see a lot of FLIR hardware wherever I go at times. So, doing the right things by the way I see things. But the topic of thermal imaging today, Jason, I mean, for those that, maybe are new to the world of reliability or even to thermal imaging, how does thermal imaging work? Just for those that, want to learn a bit more, first of all, that are just starting out on this.
Yeah, certainly. I mean, from a maintenance perspective, excessive thermal energy can cause a lot of problems. So thermal imaging is a technology, is a device which allows you to visualize that excessive thermal energy, or the thermal energy being emitted by a process or a component. It doesn't always mean it's a bad thing, but having the control of a thermal imaging camera gives you the ability to see what's invisible. So, for example, if you have a loose connection on a contactor, over time, that can create potentially a fire. And if you can visualize and identify that anomaly early on with a thermal camera, it allows you to solve a problem before it happens. But essentially what the camera does, if you have a lens on the front of the device, the infrared energy passes through that lens, strikes onto a detector, an infrared detector inside the camera, and that's then converted electronically into a visual image. And we use an array of colours to show differing areas of thermal energy. And it's a very visual tool. It's very easy to interpret what the camera shows you initially, but then you also have the ability to really dig into the details and start to analyse thermally using what's called a radiometric image, which essentially means it's an image which contains thermal data, temperature data for you to be able to analyze.
Oh, excellent. Perfect. That's nice and simple. I think that is for most people to take there. So, what are the sort of main applications that people would use the thermal imaging camera for? Then, Jason, in industry, for example.
I mean, generally from an industrial perspective, it would be for maintenance purposes in regards to identifying if there's any potential issues mechanically or electrically. But that said, it can also be used for processes. For example, if you have a process which maybe generates heat during as it continues, you allow it to monitor over time, because some of the cameras have video capability as well, so radiometric video, so you can capture a video of a process and then you can analyze that frame by frame. But certainly maintenance is the main driver from most maintenance applications, but you also have the ability to use thermal imaging cameras for monitoring buildings, for example, building surveys, building envelopes, energy loss, are windows and doors fitted correctly? Is there infiltration of cold air to a building? Is there exfiltration of warm air out of a building? These are all things that you can visualize with a thermal camera. So the beauty of thermal cameras is the diversity of use. And when we talk a lot about return on investment in this type of business, where someone invests a certain amount of money into a piece of equipment, when does that piece of equipment kind of pay for itself? And from a thermal perspective, it can be relatively quick. But ultimately, it also gives you that flexibility to try different types of applications. So I'll give you a real life example. Is I visited a customer to sell a thermal camera for electrical mechanical maintenance. And we went through some surveys of a couple of control panels. We found a couple of issues, which was great. But then we started to talk about the processes within that manufacturing operation, which was, for example, manufacturing sachets of cappuccino, in this case, amongst other things. Mm-hmm. But there was no way to actually kind of monitor the performance of the sealing machine without using thermocouples, for example. So there was wires draped over where they then use like a hard point of contact to take the temperature. I then explained they could use the camera that they were looking at for maintenance to also take an image of a batch of these cappuccino sachets. And I asked him to, would we be able to do that? And I did. 16 sachets, and you could see where the glue was cooling. It was thicker where it was warm, and it was thinner where it was cooler. That was another application. We then talked about water leaks. One of the biggest applications globally for thermal imaging is water leak detection, because the beauty of water, when it evaporates, it's a cooling process. So the thermal cameras can pick it up really, really easily. And because this was a food site, they had concerns if they have water leaks around machinery, they can have problems with Legionella, for example. That was mentioned to me. So they could then use the camera for detecting water leaks. So we kind of expanded the conversation in that case, where the customer was finding out new applications that he wasn't even considering. So the beauty of the technology is it's got so many applications that you can benefit from the use of thermal cameras.
No, that sounds absolutely great, Jason. I mean, I guess in a way, once people understand thermal imaging and how it actually works itself, you could apply that then to all sorts of things, really, that you wouldn't even see or see online or see in printed media, for example. I've had times where people have asked about water pipe leaks behind walls, and that's a prime example there where thermal imaging can help, can't it? Where you see that cooling effect and whatnot as well. So yeah, that's brilliant. When it comes to predictive technologies, when you're looking at reliability-based programs in sites, there's lots of different tools and things like that you can actually work together to help you as well to get a better picture on what's actually happening. In my experience, when we're using ultrasound in plants, one of the good areas I've seen where we've had a really good overlap in the technologies is using ultrasound and thermal imaging together for like electrical inspections. Yeah. So, you've got your thermal image that's showing you your heat buildup, your resistance, for example, and then the ultrasound is picking up the emissions of the discharge, for example. They kind of marry up really well. And have you seen things like that before in your time?
Yeah. I mean, it's really the same type of application. It was electrical utility, so it was a high voltage application, and I was out on a substation, and we were also using acoustic imaging camera, which we'll talk about later. So the acoustic camera was picking up partial discharge, but I was able then to confirm with a thermal camera the exact same position was also generating that excessive thermal energy. So it was good in that case to be able to use two pieces of technology to confirm that the issue was there as we'd expect. So there have been cases like that certainly in my time.
No, absolutely. And, you see it in industry. Some people will rely heavily on sort of one technology, but unfortunately, there's not one technology out there that can do everything. Otherwise, we'd be out of a job. I think we'd say there. But, it's great that you can see that combination and we kind of promote that sort of education in people about looking at types of failures or problems that they want to identify and what technology they can use to help them around those sort of things. So that's, exactly that sort of thing. I think thermal imaging does pair up really well with other predictive technologies to, help the user actually almost build a business case to operations as to say, hey, I need this down because this is what I'm finding, here's my evidence. And I've seen that a few times now. I had one from a customer who was a service provider doing electrical inspections in I think it was a plant room in a building, a banking sector building. And they were just doing a courtesy check of the new installations of some transformers. And they had ultrasound with them and they had thermal imaging with them. And what they did was that they'd go into a room, first of all, and scan the room with ultrasound to listen for anything that might be abnormal. If they don't pick anything up, then they bring out the thermal camera and they start doing their routine inspections. But what they did is they picked up some low-level crackling noises in the ultraprobe as they were scanning. So they started to then move around, listen to where the sound was coming from. And they found it was coming from some 400-volt cables coming off of a transformer. Now, they then pointed where they thought it was coming from. They took the thermal camera out and they could see a very small hotspot between these two cables, very small. And this was a new installation as well at the time. So they kind of said to the customer, look, you've got a serious problem here. We need to do some remedial actions quite quickly. But they didn't believe him. They were kind of like, no, this is a brand new install. This can't be wrong. So what they did was they took the thermal image, they did a sound recording. They turned the lights out and pulled their phone out, and they could see tracking occurring between these two cables at a very lowest level. But again, you couldn't audibly hear it. If you would have scanned past it initially, you may have missed it because it was only a small level of heat. But they used those two technologies and the video recording to show to the customer. And eventually the customer's like, yeah, actually, this is a problem. So it was a great example of how the two technologies kind of work hand in hand to build yourself a business case, really.
Yeah, I think as well with the beauty of having that evidence, and because it's visual evidence as well, especially when we talk about thermal imaging or acoustic imaging, it's a visual perspective that you're looking at. A picture speaks 1,000 words is the old adage, and it's pretty true. I mean, you could show a child a thermal image of a hot fuse against two normal operating fuses and say which one's hot. The child can point out which one's hot. That's kind of the visual interpretation. And it's then a case of, okay, well, why is it hot? That's when the interpretation of what a thermal image is telling you becomes more important. So, for example, if you've got three circuits which should be under the same load, with three main incoming fuses, but one of those fuses is emitting a lot more thermal energy than the other two, then we've clearly got a bit of an issue going on here. We need to find out more. And that's when other tools come in. So, what a lot of people don't know about FLIR is we've got a wide range of test and measurement equipment as well, but we're not really known for that in the industry. But we've got some fantastic test tools, including clamp meters, for example. So you could use a clamp meter to check the current on each of those circuits. We can be using vibration analysis, for example, which is another solution within the FLIR portfolio that we have, which people aren't really that aware of because they just think of us as a thermal imaging business. But that's where these different pieces of equipment, different tools, different technologies can be used in combination. So there's a synergy between some of these tools, which you're much better having two technologies than one, because it opens up your ability to find those more hidden problems. And the beauty of something like the example you just mentioned, there's a perception that if a piece of equipment is new and the installation is new and it's just being commissioned, it must be running perfectly. But the simple fact is life isn't like that, because there can be an inherent problem which might not reveal itself straight away. But then if you then go and check other pieces of similar equipment, which I've done actually with acoustic camera, where we found a leak in a particular junction, And I said, let's just go and check those other machines. And it turns out it was a manufacturing issue. It was an issue with, degradation over time, because they were all the same problem in the same place. So it's being able to identify and highlight those things. And as you say, being able to prove it to a customer, look, there's the evidence. That's kind of the key sort of deal maker, really, when it comes to trying to provide a solution.
Yeah, absolutely, Jason. And I mean, you hit the nail on the head there. I mean, only a few weeks ago, I had somebody say to me that condition monitoring would only be relevant on a plant after a couple of years of it being run.
No.
And I kind of tried to educate them on failure mechanisms and failure curves and things like infant mortality or installation issues or even manufacturing issues.
Yeah.
So, yeah, absolutely. And the example I just shared there was a prime example of that. And it turned out that it was actually on installation. It was cables were mounted far too close together, causing neutral inductance, heat buildup, and there was the problem with the insulation. Yeah. So, I mean, it just, like I say, starting any sort of condition monitoring with any technology is always best to start it at the beginning. So that's great. And I mean, that goes on to one of my next questions, Jason, because, when people are thinking about starting a condition monitoring program or considering actually, investing in thermal imaging, what would you say, being, with your vast level of experience and knowledge, what would be the key considerations prior to even, looking at cameras? What do they need to really be considering?
If I'm going to be, honest, the first thing you need to have is the confidence that you can use the equipment. I think because this is anography, it's a thermography, there's a perception, you've got to study for years. And, I'm qualified up to a level 3 thermography through infrared, the infrared ITC infrared training centre that we have within our business. So I've done kind of the theory side of things, and I'm experienced when it comes to that part of the knowledge. But people need to believe they've got the confidence to use the equipment. There's been, bearing in mind, I've been involved with selling thermal imaging solutions since probably 2009. We can provide those solutions, and then you go back maybe 3, 4, 5 months later on another subject, and you find out the piece of equipment is sometimes even still in the box, because it can come down to resources. But there's an element of, we're not sure we're going to get it right, or what's it telling us. So the first thing I'd say is have the confidence to know that you will be able to use the equipment. Certainly from our perspective as a manufacturer, we manufacture our thermal imaging solutions to be easy to use. And that runs right through the range, right from the entry point, the ones which connect with your mobile phone, right the way through to the higher end, certainly from our perspective as a portable solutions provider. So confidence is the first thing you need to have. Believe that you can use the equipment. And then it's a case of really, well, what are you trying to do? Are you into a kind of a find and fix scenario where you just need to find an issue and fix it? Or are we talking about what this podcast is about, which is about the predictive maintenance side of things and those technologies which can help you get a program up and running? And ultimately then it's about how do you capture the data? So all of our cameras can interact with various pieces of software, but it's what do you want to do with the data? Do you want to store the data? Do you want to be able to start trending with the data? Are you going to do monthly, quarterly, annual reports? Because I talk to a lot of customers who do an annual inspection, sometimes provided by a third party. But an annual inspection in an industrial site, I have to question what's the validity of that inspection once a year. You should be looking at your critical assets far more than that. So even if you have a blanket annual survey for the site, that's fine. But if you've got critical assets on that site, which if they go down, you've got a serious problem. That needs to be something that's got to be more repeated more often. Ideally in a way which fits in with your resources as a maintenance organisation. Because that's another thing I've noticed in the last 25 years in particular. Maintenance departments have to do more with less. Generally,
Absolutely.
It's usually less budget. It's usually less people, unfortunately. So the technologies that can allow you to be more efficient. And we've introduced things into our software, for example, which we'll talk about later, which can really help with these kind of programs on an ongoing basis. It makes them easy to follow and makes the equipment easy to use as well. So certainly from that perspective, it's a case of what's your application, what do you want to do with the thermal imaging technology? Are you trying to create a program, or are you just trying to find your feet with the technology, get used to using thermography? Because it's not the panacea for everything, but it's a fantastic technology if you can actually learn how to use it effectively. It's not difficult to do. There's some terminologies and some funny words like emissivity, which, we can Google that one later on. But essentially, there are words which you will not have seen before or not come across before, which is certainly the case for me when I started dealing in this technology. But ultimately, the cameras are easy to use. They can tell you very important information, and they allow you to record that information. Because, the old saying, the old quote was, knowledge is power. Well, I believe the application of knowledge is power. So it's understanding what to do with that information. And we've certainly provided solutions within our portfolio, within the FLIR family, where we believe that we've managed to do that to a degree which can be a major benefit, just like UV systems.
No, that's great. That's perfect. The hardware is kind of like one side of this, isn't it? And then, like you're saying, to what level people are trying to go. But if someone's trying to go into a sort of like a predictive maintenance program where they're going to start doing baseline readings and then regular checkups and comparisons and things, obviously there's going to needs to be like a software platform or something like that to be able to then store that data, build routes and things like that. And, is that something that FLIR provide as well?
Yep, certainly. I'd say it's the thing we've spent the most effort developing over the last few years is to really enhance the software platform to provide a really good full solution for users of our equipment. Now, we have kind of the two main platforms we have. One of them is cloud-based, which is called FLIR Ignite, and one is a desktop program, which is called FLIR Thermal Studio. Now, the big difference straight away is one's cloud service and one's loaded onto a PC. The advantage of the cloud service is FLIR Ignite is kind of a DNA thread that runs through the whole portable range that we have now, apart from the very top of the range camera, because it's an older platform. But every other camera we have is compatible with FLIR Ignite. So, for example, you might have a FLIR One Edge Pro, which is one which connects to your mobile phone. You might have a C3X or a C5, which is a small compact device. But even from that range upwards, you can pair your camera to an account that you create. So you have a FLIR Ignite account, which is paired to a camera, and up to 1 gigabyte, it's free. So anybody can set up a FLIR Ignite account now. They can sign up on our website, and they'll get access up to 1 gigabyte of data. And if you think some thermal images are in the hundreds of kilobytes, even 1 gigabyte free, that's a lot of information to start playing around with and working with and really developing your understanding. So FLIR Ignite is definitely one that anyone can do now. And it is compatible with the majority of our range. It also means that you don't have to load any software onto your PC. So if you've got any kind of issues with IT sentinels, and anybody who's watching this will understand that the IT sentinels can create a lot of problems in regards to what you can and can't do with your PC, for good reason most of the time. Just ask Marks and Spencer recently after the issues they've had with online situations. Yes. So security is really important. But if you do have issues loading software onto your computer, using FLIR Ignite means you don't need to load anything. You just need to have access to the internet. And then you also have the ability to automatically send your images to your cloud account. So if your camera's got a Wi-Fi connection, it will automatically copy those images to your cloud account. And the beauty of FLIR Ignite is it's a collaborative program. So it's designed to be able to be used by numbers of users. With the FLIR Ignite Pro, it's 1,000 plus connections you can have. But basically, if you have a team of people collecting data, they find an anomaly, the anomaly gets sent to their cloud account. The administrator who might be sitting in an office 400 miles away can access that account and look at that image almost immediately. So it's that connectivity, the collaboration you can have with FLIR Ignite. It's not just about single users. And you can also send other files and other data using FLIR Ignite as well. So that's the cloud service. Thermal Studio being a desktop program. So if you purchase a single license, it gives you 2 activations on 2 different devices, but those are not connected in any way. So you need to work out how you're then going to store and work with the data. But Thermal Studio Pro in particular is a much more functionally, much more comprehensive software solution, which also includes a couple of really good features. So, for example, batch processing means that you can make changes to your images once you've downloaded them. So after you've captured them, you can make changes. So you may change the color palette. You may want to add markers. You may want to change different parameters within each image, and then you can do that to 100 images, 500 images, 1,000 images. So this batch processing is a really good feature. You have a panoramic feature where you can stitch images together if you don't have enough space to take, for example, might be a large building, the fascia of a building which you can't fit onto one image. But the key thing with Thermal Studio Pro is the routing software that we have within it. And inspection route is firmware which is loaded onto certain cameras in the range. So we have a range called the EXX, which is the E54, E76, E86 and E96. Then we have T530, T540, T560, T865, T840. So all those cameras are compatible with routing. And what it basically means is you can use your FLIR Thermal Studio. You use the routing functionality on the software to create a route. So let's keep it really simple. Switch room A, panel 1, fuse switches 1 to 5. That could be the first part of your route. You build that into the software. You create essentially like a cascading report. You then load that route onto your camera, and then you trigger the inspection on your camera, and the camera then becomes a guide. It will then tell you to go to that particular location, which images to record. You also have a reference image capability. So if you are trending over time and you want to take an image a month later, you can recall the image you took a month previously and you use it like a ghost image. So you can line up to ensure you've got the same distance, same perspective, because the more you can repeat the conditions on your next thermal survey, the more accurate the information is going to be. So I've rambled on a bit there about the software, but FLIR Ignite cloud-based, Thermal Studio Pro in particular for routing, desktop-based, but two very, very capable pieces of software that we've spent a lot of time and investments in developing.
It sounds you're quite passionate about that as well. And to be fair, I think it's really important. It's really important to make sure that you have the right platform to go along with the hardware.
Yeah, definitely.
So I appreciate that Jason, and it's going to give plenty of people something to think about there as well. And some of the things I've seen as well, if people would have seen on social media, on LinkedIn or in the press recently, the partnership with UE Systems and FLIR together, collaborating with technologies such as things like acoustic imaging that actually is also feeding into your software platforms as well as the UE platforms too. And that's been quite a success, I think, Jason, the introduction of the SI series of cameras and whatnot. I don't know if you want to have a little bit of a spiel on those as well, actually.
Yeah, again, we go back to the start, the introduction, FLIR forward-looking infrared was seen to be the thermal imaging company, but before I joined the company, which was March 2020, a bad month for anyone who remembers the start of the nasty pandemic. But ultimately, FLIR were in the acoustic imaging area prior to me joining the company. So we'd launched a product which was called the SI124. It was our kind of first iteration of an acoustic imaging camera. It came with a big shoulder battery and it was a tethered cable. We then developed that to become a battery which was included in the camera rather than being a tethered battery. And then last year we launched the SI2, March 2024, which is kind of our first kind of full FLIR developed acoustic imaging camera. And we've also recently launched the SI1. We have the ability to provide a model called the SI2X now, which is a hazardous area camera as well, which coincidentally we also have a thermal solution for EX rated areas as well. But the acoustic imaging was kind of a new thing for FLIR, considering we've been involved with thermal for so long. But it's that, it's what you spoke of before. It's that synergy between different solutions, different technologies, but can give you a better expanse to look at. When we talked about the commission of new equipment and installation of new equipment, we look at this curve where, you design something, then you install it, then over time it will degrade and eventually it will break down. And, what we're trying to do is we're trying to either extend the curve as long as possible or prevent the breakdown. And the best window you can have is kind of the ultrasonic window. You're going to pick up on those issues earlier on. With the type of equipment that the traditional ultrasonic equipment that UE Systems are certainly well renowned for. But also we have that ability now to also go into the ultrasonic realm where, we can all hear certain things, like whether it be crackling to do with electricity or it's hissing to do with leaking, but it's those ones you can't hear because it's outside the realms of human hearing. So we've certainly found that we've provided a platform and we've developed a platform now which and again, I'm biased, I work for the company, but we've got a fantastic solution for acoustic imaging now. And it's the ability to, with the SI2, you can quantify different gases. So not only does it identify leaks and you can locate them and you can fix them, and some companies love the find and fix aspect a lot. But then if you're an energy stakeholder within a building or within a company and you need to reduce your energy costs by X% per year, you can actually have the data. We talked before about having the evidence to show your customer. Well, ultimately, you can have numbers to say, well, okay, this leak is going to cost you £100 a year, or that leak's going to cost you £1,000 a year. So it's having that ability to have a different technology, providing different information, but it's also can be enhanced by whether it's thermal or whether it's acoustic. So it's still something that a lot of people maybe not familiar that we're involved with, because they keep thinking down the thermal route. But we've really developed a good range of acoustic cameras now. Well, no, they're an excellent range of acoustic cameras. And it's that ability to be, even it's still, we've still managed to put all of the technology within this single-handed unit. And it's kind of, people can you can have a two-handed unit, which can do a great job. But if you're trying to look around in a particular location, and I've literally had a case this week, being up in Scotland doing a demonstration with SI2 X camera. I was able to use the camera to really get in behind machinery and look at the pipework behind these areas where there's no way you would get a bigger device in there. So it's having the flexibility to have a device which gives you, and even from a safety perspective, even if you've got to hold on to something, the simple fact is you've got a hand free, which, in certain scenarios can be really important. So we've managed to put a lot of power, even from this partial discharge perspective. We've got a device now which will give you a live result at the time. So it will tell you what type of partial discharge it is, as long as you put in 3 parameters, the distance, the line voltage, and your type of connection. But the device on the screen will say, yeah, you've got a problem here with, for example, corona. So the air around that fault's energized. Yeah, you've got corona problem here. It gives you recommendations, but it also gives the ability to save that data and then use it in the software. So, acoustic imaging it's grown massively for us in the last few years, and now we have SI1, which is just for compressed air, but a fantastic platform. We've got the SI2, which does the multiple gases as well, which includes nitrogen and CO2 and ammonia and argon and hydrogen, natural gas. It doesn't identify different types of gas. That's important to clarify. But if you know what's in the system, you can now quantify all those other gases as well, based on the parameters within the camera. So these tools are, and again, what's the old adage? The only thing more contagious than enthusiasm is a lack of enthusiasm. Well, when it comes to what we do, I can be very enthusiastic because I believe in it as well. So from that perspective, we've got some really good solutions now.
No, that's great. And I agree with you. They are fantastic solutions and they can give you a very quick return on investment there. And a point to add to what you were saying there about, be able to quantify the costs of energy and things like that for stakeholders. A lot of industries these days are also looking at reducing their carbon emissions. And through the reporting as well, you can see the carbon emission offsets as well from that energy usage too. So they're key technologies for those sort of things, not just from a predictive maintenance, but from an energy savings program and things like that. It's one of the easiest ways to start bringing down your energy costs and things like that as well. So no, I mean, Jason, we could go on forever, I think, couldn't we, on one of these calls? And I think there's room for another episode on those sort of acoustic cameras and that. And I think we maybe get together again in the future and do that. But I'm going to have to wrap up, though, for today, I think, Jason. It's been a pleasure having you on board.
Thanks for the invite.
No, absolutely. And we'll be seeing you probably at a few shows in the near future as well, over at Main Tech in the NEC.
Yeah.
The recording might go out after that, to be quite honest, but, it's always nice to have a mention there. One thing I will mention to everyone is that to save the date for the 2nd of October this year for Talking Reliability Conference, a live show based off these podcasts where you'll be able to come and see myself and Jason and quiz him to hell and let him tell you more and more about the stuff that he's passionate about. And save the date, 2nd of October. But with that all said, Jason, thank you very much for your time today.
Thanks, and
been a pleasure. Everyone, keep tuned for the next few episodes of Talking Reliability. Thank you very much.
Thanks.
Take care.
Bye now.